Okay, in this video, we're going to be doing trigonometry with right triangles, but this is part 2. And in part 1, we found missing sides. In this video, we're going to be finding missing angles. So it's still really important that you know these formulas. This was the first slide in the last video. So if you need to go back and watch that, do that. But you need to know sine, cosine, and tangent and their formulas, as well as the relationships between the sides of the triangle based on the angle that you're looking at. Okay, so review that if necessary. Let's look at our first example. On our first example, we're asked to find the measure of a specified angle and to round to the nearest tenth. So this is the angle we're looking at, but we do need to identify our sides. So this is our 90-degree angle. Remember, if we go across from that, this side is going to be our hypotenuse. And then looking at this angle that we've called theta, the side opposite it is 7 in this case. So this is our opposite side. That makes this our adjacent side, and it's important to know which side you have. So we have the opposite side and we have the hypotenuse. So that's what we're going to use. So you got to think about your trig formulas and ask yourself, well, which formula has opposite and hypotenuse? And that is going to be sine, but in this case we're saying sine of theta because we don't know what this angle is. This angle right here, we don't know it. So we're going to say sine of theta is equal to opposite over hypotenuse. Now the question becomes, how do we solve for theta? We want to get theta by itself. Well, you do that actually by taking inverse sine, which looks like this. This is the notation of each side. So I know this looks a little strange, but we studied inverse functions, just not trig inverses. And so this is inverse sine. And when that happens, what you actually get out of it is you just get theta. So this sine inverse and sine essentially cancel each other out. And you get theta is equal to sine inverse of 7/12. And then the nice thing is, this is calculator work. So you do sine inverse in your calculator. You need to find that button of 7/12. And when you do that, you actually get that theta is equal to 35.7. And since it's an angle now and we're in degree mode, we're going to say degrees. And you do need to make sure that you're in degree mode for this problem. We're asked to round to the nearest tenth. So we did that. Okay, in this example, we're going to find our 90-degree angle, which is right here. So the side opposite it is our hypotenuse. And then we're talking about this angle. This is the angle that they've called theta. So we're going to go directly across, and this is my opposite side. That makes this side over here adjacent. And so now these are the two values we have. We have adjacent and we have opposite. So we have to ask ourselves which trig function gives us a formula with adjacent and opposite, and that is going to be tangent. Tangent of theta, because we don't know our angle, that's what we're trying to find, is equal to opposite 11.3 over adjacent, which is 8. So this was opposite, remember, over adjacent. So you do have to know your rules. When I have this here, I need to get theta by itself. So we're going to take tan inverse of both sides, which looks like this. Now these two tangents over here are going to cancel each other out, and I'm going to get theta is equal to tan inverse of 11.3 over 8. And once you get to that point, it's just calculator work. And our calculator gives us 54.7 degrees. So this is all about knowing your relationships and your formulas. And then what we're adding to this now is how to solve for using inverse trig. So tan inverse and tan, they cancel each other out. So when we're trying to solve for an angle. Okay, I want you to take a minute and I want you to try this problem. Okay, in this example, like always, here's my 90-degree angle. The side directly across from it is my hypotenuse, which we happen to be given this time. This is the angle we're looking at. So going across here would be my opposite. That makes 8 the value of my adjacent side. So we have adjacent and we have a hypotenuse in this case. So we're going to set this up as cosine of theta. Remember, cosine of theta is equal to adjacent over hypotenuse. And so now we're just going to plug in. We don't know theta. Theta is what we're trying to find, but we have our adjacent value is 8 and our hypotenuse is 10. So all we need to do is solve for this theta right here. So we can say cosine inverse of cosine of theta is equal to cosine inverse of 8 over 10. Now remember, we only have to use this inverse when we're trying to find the angle because we're missing theta here. So this is going to give me theta on this side is equal to cosine inverse of 8 over 10, and that's calculator work. Theta becomes 36.9. We're putting degrees because we're trying to find an angle. So this angle here is 36.9 degrees. Okay, why don't you pause the video, go ahead and try this one as well. Okay, first step, here's my 90-degree angle. Side across from it is my hypotenuse, which we're given in this case. This is the angle we're calling theta, so we're going to go directly across from it, and 6 is my opposite side. That makes this adjacent, although we don't have this value, so we're probably not going to use it. I'm going to look at the fact that I have hypotenuse and opposite, and I'm going to go, I must need to use sine for that. So the sine of theta, because theta is what we're trying to find, this angle right here, is equal to opposite over hypotenuse. And now we're going to plug in what we know. We still don't know theta, but we do know that the opposite is 6 and the hypotenuse is 14. Remember, to solve for an angle, we're going to use inverse sine on each side. And then these cancel, so we get theta is equal to sine inverse of 6 over 14. Theta is equal to 25.4 degrees. Okay, in this example, it's a little bit different because it says solve the triangle. Solve the triangle means we want to know every missing side and every missing angle. So let's look at this for a second. This is angle A, and notice we use capital letters. So what we usually do to identify our sides is across from angle A would be side lowercase a. Across from angle B would be side lowercase b, and across from angle C would be side lowercase c. So what we know is we want to find angle A, angle B, angle C, and we want to find side A, side B, and side C. So let's see which ones do we already know. Well, we already know that angle A is equal to 38 degrees. We actually already know that angle C is equal to 90 degrees. That's what that box there means. That's our right angle. And we happen to have that side C is 13.3 degrees, or 13.3 units, whatever our measure is, okay? So now we need to use our trig that we know to find the remaining values, the missing values. So I'm going to start with this angle here, and I'm going to say if I'm using this angle, this side over here would be opposite, this would be adjacent, and this is opposite my right angle, so this is hypotenuse. So it's directly across from my 90-degree angle. So I can use trig that we know to find the missing value A here, or the missing value B. So if I want to find A, this would be the opposite side, and I know the value of the hypotenuse. So I'm going to say sine of 38 degrees is equal to opposite, which is A, over hypotenuse, which is 13.3. And then this was from our last video, part 1. I'm going to multiply both sides by 13.3. And I get 13.3 times sine of 38 degrees is equal to A. And again, all of this over here is calculator work. And so we do that, and we get 8.2. So A is 8.2 units. Now, I'm going to use this same angle right here, but I want to find B, and B is the adjacent side, and I have the hypotenuse. So I'm going to say cosine of 38 degrees is equal to adjacent, which is B, over hypotenuse, which is still 13.3. Again, I'm going to multiply both sides by 13.3. And so I have 13.3 times cosine of 38 degrees equals B. Okay, and then this math gets done in a calculator here, and we have that B is equal to 10.5. So at this point, we found all the side lengths to the nearest tenth, which is what we were asked for. Now we just need to find B. You have this angle here, which is 90 degrees. You have 38 degrees here, and we know that there are 180 degrees in a triangle. So basically, 90 degrees plus 38 degrees plus the measure of angle B, which is what we're missing in this case, this one here, should equal 180 degrees. And so of course you can put these together and subtract from this side, and when you do that, you get that angle B is equal to 52 degrees. And now we've found every angle and every side, and that is what it means to solve a triangle. Okay, on this example, it's just a little bit different because we actually the only angle we have at the beginning here is 90 degrees. We don't know B and we don't know A. So we do have two side lengths. So we're gonna start and we're gonna say this side must be lowercase a because it's opposite angle A. This side over here is lowercase b, and this side would be lowercase c. So we wanna find angle A, angle B, and angle C. We also want to find side A, side B, and side C. In this instance, A is what we don't know. B is 9 and C is 12. So we have two of the three sides. Angle C, we do know, is 90 degrees. Okay, so I'm going to use trig to find one of these angles. Let's start with angle B. And if we use angle B here, we're going to just call it theta for a second. You could work with angle B, you could work with the letter B, that would be fine. But if we call it theta, then this side becomes opposite, this is hypotenuse, and this is adjacent. So if I want to find angle B, I have to use the two that I have values for. So this is opposite and this is hypotenuse. So I'm going to say sine of theta, or sine of B, doesn't matter, is equal to opposite over hypotenuse. And remember, I'm going to use inverse sine to solve this. Inverse sine of both sides gives me theta is equal to sine inverse of 9 over 12. When you do this part in your calculator, you get 48.6 degrees because we're trying to find an angle. So we're going to put that up here at angle B is 48.6 degrees. Okay, now we talked about this in the last one. I have two of my three angles now, so I can actually find angle A. So I can say 180 degrees in a triangle. So angle A plus angle B, which is 48.6, plus angle C, which is 90 degrees, have to all add up to 180. And then I can solve for angle A, and you all know how to do that. And when you solve for angle A, you actually get 41.4 degrees. Now, we're gonna put that up here. We only have one thing left. We have side A. So you could actually find that using Pythagorean theorem if you wanted to, a squared plus b squared equals c squared, but we can still use trig to find that. If we're trying to find angle A, or side A right here, then we can still use this angle, and we can use adjacent over hypotenuse. Or we could use opposite over adjacent. I am going to use adjacent over hypotenuse, which is going to be cosine. So I'm going to say cosine of theta is equal to adjacent over hypotenuse. Now, we happen to know theta now. We know that cosine of theta was angle B, which is 48.6 degrees, is equal to adjacent, which was A, and hypotenuse, which is 12. Then we can multiply both sides by 12. Again, this part was from video 1, and we get 12 times cosine of 48.6 degrees should equal A. And when we do that math in a calculator, we get that A is equal to 7.9. So let's write that up here. Now we found every side and every angle. Okay, this is the last one. Why don't you pause the video and give it a try? Okay, remember we're asked to solve the triangle, so we want to find angle A, angle B, and angle C. We want to find side A, side B, side C. Remember that this is angle A, so across from it, this is side lowercase a. Angle B makes this side B. This is angle C, which makes this side C. So I actually already know that angle B is 33 degrees, and we know that angle C is our 90-degree angle, so we can write those two in. I can also go ahead and find angle A since I have two of my three angles. Remember that there's 180 degrees in a triangle, and so angle A plus angle B, which is 33 degrees, plus angle C, which is 90 degrees, should all add up to 180. When you solve this, you get that angle A is equal to 57 degrees. So now we know all three angles. We're going to use trig to find our sides, okay? I'm going to stick with this angle since this is the angle they gave me. And based on this angle, well, look at our 90-degree angle first. This is our hypotenuse. But based on this angle, this side over here is opposite, and this side is our adjacent side. So knowing that I have this angle and I have our adjacent side, I'm going to set up opposite over adjacent, which is actually going to be tangent. So tangent of theta is equal to opposite over adjacent. And now we know theta to be 33 degrees. We know that our opposite side is labeled B and our adjacent side is 11. So I can multiply by 11 and I get 11 times tangent of 33 degrees is equal to B. Doing that in my calculator, I get 7.1. Okay, we can do the same thing to find C. C, though, is our hypotenuse, and we know our adjacent side, so I'm going to do adjacent over hypotenuse. So I'm going to set up cosine of theta is equal to adjacent over hypotenuse. Again, we do know our angle. We're using the angle that's 33 degrees. Our adjacent side, in this case, is 11, and our hypotenuse is C. So remember, I can multiply both sides by C. So C times cosine of 33 degrees is equal to 11, and then I can divide both sides by cosine of 33 degrees. So C is equal to 11 over cosine of 33 degrees, and doing that math in my calculator gets me 13.1. And we already had A. A was 11. So now we've solved the triangle.